Okay, so this chapter we will be looking at metals, and all your metals we have learned from the periodic table that um, they are quite reactive. They will tend to lose electrons to form cations. Okay, so we actually have to rank all the metals according to a reactivity series. Okay, so periodic table, recall, right? Group 1 metals are the most reactive metals, right? Atomic radius increase due to increased shell. All right, so period 1 has 1 shell, period 2 has 2 shells, period 3 has 3 shells. My lithium got 2 shells, sodium got 3 shells, and potassium got 4 shells. So as the shells increase, there's weaker electrostatic force of attraction between the positive nucleus, that's where all the protons are, and the valence electrons. The valence electrons are delocalized and they are moving around. Okay, and this leads to weaker electrostatic force. So it is easier to lose this valence electron, and then the reactivity increase down the group. Okay, so position of this reactivity series will be used to explain reactions with water, steam, acids. Okay, so let's look at this is the reactivity series, very important. Okay, so I remember the reactivity series by popular scientists can make a zoo in the lab, however, cannot make silver gold. So quite easy to remember. What can popular scientists do? Make a zoo in the lab, however, they cannot make silver gold. Okay, so P refers to potassium, group 1 metal. S, sodium, still group 1. Okay, calcium can. Okay, group 2, magnesium, make group 2. Okay, aluminium, group 3. So if you look at the reactivity series, right, potassium is below sodium. Potassium is below sodium, we already know reactivity increases down the group. So potassium is more reactive than sodium. Okay, and my group 1 metals are the most reactive, therefore they are at the top, right? First two, group 1. Okay, then calcium, magnesium, likewise, my calcium is below magnesium. Calcium is more reactive, that's why it's at the top. Then I have aluminium, which is my group 3. And then I have my transition metals. We have to memorize this. So do in the lab. So zinc, iron, tin, lead. Okay, however, this is hydrogen. Okay, later we will see what is it for. Most of the time, this is for acid. Okay, and then unreactive metals over here cannot copper, mercury make silver, gold. So these are unreactive. Right, so if we break down your reactivity series, it is actually not so hard to memorize them. Okay, so we will look at how your metals react with cold water, steam, and acid. So still the same reactivity series, okay? I added carbon over here, and sometimes I remember it as can make a concrete zoo. Okay, so still the same reactivity series that we have remembered. Okay, your group 1, group 2 metals. Group 1, group 2, they react with cold water. So generally, we have to see a trend, right? My potassium react violently, explosively, sodium vigorously, readily for calcium, and then magnesium is slowly. So reacting with cold water, we have to know the flame color, especially your potassium and sodium. So lilac flame, yellow flame, your potassium and sodium. Okay, so what will happen when metals react? So for example, my potassium react with H2O. Okay, when I write a chemical reaction, right, the most important thing, and as I have taught you all, is always the positive, kick out the positive. So my potassium is positive, but water is H plus. OH minus, we have to know this. It's not H plus, O2 minus, okay? My acid alkali give me water. Okay, so my K will go and kick this H plus out. K will partner the OH to form KOH. This is my alkali. And then the H is being kicked out, forms H2 gas. And then we balance up your equation. Okay, so that's why your group 1, we get your metal hydroxide. Okay, in fact, your group 2, reacting with cold water, we also get the hydroxide and hydrogen gas. Okay, next one, we have reacting with steam. So same thing, we will have a trend, okay? Because group 1 metals are very reactive, they will still react this way, violently, vigorously, readily, slowly with steam. Okay, your magnesium will also react violently, explosively with steam, right? And then we will see a white glow. Okay, so once I heat reacting with steam, this one we will get the oxide. Instead of the hydroxide, we will get the oxide. Okay, very important. Right, so usually in this reaction, right, I will actually write in the state symbol because this is cold water. And then, for example, if I have magnesium again with H2O, but now my H2O is steam, right? This one will get MgO plus H2. Okay, so we have talked about the group 1, group 2, right? Let's look at your transition metals. So transition metals can also react with steam up to iron. Okay, so same thing, this reacting with steam is explosively for anything that's from magnesium, from potassium to magnesium. Then my zinc will be readily, just show a trend in the speed of reaction. All right, okay, and then my iron is slowly. Okay, important thing is we have to know the color. My zinc oxide is yellow when it's hot, white when it's cool. Okay, and then if I see a black solid, it will be my iron oxide. Okay, and then last but not least, we have reacting with acid. So all your reactive metals that's above hydrogen, because my hydrogen, in this case, I'm not talking about H2, but H plus the acid. Okay, so all these metals will react with acid to give me salt and hydrogen gas. If you don't remember how to write the equation, please refer to your acid-base videos. Okay, and likewise, because these metals are less reactive already, so they will all react slowly. Okay, and these metals, copper, mercury, silver, gold, they are unreactive. There's no reaction. Okay, aluminium is usually not tested in the O-level syllabus, okay, but it is still important to know. Okay, aluminium is actually quite reactive, my group 3 metals, quite reactive, but they do not react with steam or cold water. Why? Because aluminium will form a layer of Al2O3, and this layer, A levels, we will know, right? It is impervious, so not permeable. It doesn't allow oxygen or water to actually react with it. Okay, the carbon and hydrogen in this box over here, we have your concrete, your carbon, as well as the hydrogen, which is here, right? Refer to your carbon and hydrogen reduction of your metal oxides, right? I will tell you that hydrogen actually moves up 2 steps, okay, to reduce the metal oxides to pure metal. Okay, so this is a typical experimental setup, right, of how we show metal reacting with either water, steam, or acid. Actually, mostly water or steam, yeah. So I usually soak the cotton wool with water and then I heat it to produce steam. So typical setup, right? The steam reacts with the metal piece over here, right? It will give me, if it's group 1, group 2, it give me the alkali plus hydrogen gas. So hydrogen gas will burn. Okay, it is very flammable, so it will burn. Okay, even though we say extinguish with a pop sound, hydrogen gas is found in um, uh, the fireworks, right? That's why we hear a lot of pop, 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 and these are all flame. Okay, so typical setup, or we also have something that set up that's like this. Same thing, I soak the cotton wool with water and I heat it with the metal. My hydrogen gas, use your water displacement. Okay,